Welcome children, welcome back to Physics and Chemistry Made Easy. Today we will be speaking something about atom. As stated by Rutherford, atom is spherical in shape and mostly hollow. Middle of the atom is a place called nucleus. Right? There are mainly three subatomic particles: protons, electrons and neutrons. So you can remember them as pen. Protons are positive charged particles, electrons are negative charged particles, and neutrons do not have any charge. Now we will see their placement. Protons and neutrons are placed inside the nucleus, and electrons are present outside the nucleus and in definite orbits, which are also called as shells. So we will come to know this in Bohr's model. Meanwhile, some more thing about the atom. Mass of the atom is, I have spoken whole atom, okay? Mass of atom is 1.008 AMU. Atomic mass unit, which is equal to 1.665 into 10 to the power of minus 27 kg. We cannot see atom without naked eye. Just imagine such a small object it is. Therefore, its mass also will be very less. And on the whole, the mass is like this. What do you mean by this? After 0.26 zeros, then starts your value 1665 like that. So it's like that. Now the next one is what? Another subatomic particle is what? Mass of electron. Now when you speak about mass of electron, it is 9.11 into 10 to the power of minus 31 kg. So it's 9.11 into 10 to the power of minus 31 kg. This is the mass of electron. Very less. You understood just now I explained you. Minus 31 means almost after 0.30 zeros, then comes 911 like that. So it's very minute. Then coming to mass of proton. Now when you speak about mass of proton, it is 1.67 into 10 to the power of minus 27. 1.67 into 10 to the power of minus 27 kg. A bit better than electron. So proton is a bit heavier than electron in the atom, because this is like minus 27. That means after 0 point, then you will have 26 zeros, then the number start. Better than this one. This is after 30 you are getting these values. So a very minute one is electron, but somewhat okay with proton. It is 1.67 10 to the power minus 27 kg. Now coming to charge. The charge of electron is negative. Charge of proton is positive. But interesting thing is what? The value for these two remains same. Only thing for electron, since it is negative, we say minus 0.602 into 10 to the power of minus 19, and the unit for charge is coulomb. Same way when you speak about proton, we say it is plus 6.02 into 10 to the power of minus 19 coulombs. Now what do you understand by these two? Charge is same. Why? Because atom is electrically neutral. What do you mean by atom is electrically neutral? If suppose you take, for example, hydrogen, its number is 1. Lithium, beryllium, boron, if you take like that, carbon let us take for example, whose atomic number is 6. Hydrogen, helium, lithium, beryllium, boron, carbon. Its atomic number is 6. What do you understand by this? 6 indicates atomic number. Atomic number means number of electrons or number of protons. Why we are using the word or? Because they remain to be same. If there are 6 electrons, protons also will be 6. That means what do you understand? Number of electron charge is this one into 6, proton charge is this one into 6. That means atom is always electrically neutral. Now let me take example carbon. Carbon atomic number is 6. That means carbon atom contains 6 electrons, 6 protons and 6 neutrons. Right? Now these electrons are distributed like this, 2, 4. Now I will explain you what is that one by one, okay? Suppose take example magnesium whose atomic number is 12. It contains 12 electrons, 12 protons and 12 neutrons. You need not worry about protons and neutrons because this is the structural form of an atom and protons and neutrons are present inside the nucleus. Then comes first shell, this is called shell. Then comes second shell, third shell. Electrons are actually revolving in these shells. These shells are also represented like this. N is equal to this is 1, first one is 1, this is 2, this is 3. These are also named as K. First one is K shell, then L shell, and the third one is M shell. It goes on. Now what happens? Distribution of electrons, very important. In the first shell, 2 electrons. First shell occupies only 2 electrons. Second shell, 8 electrons. Third again 8, but the number available for you is 12. Therefore, you have only 2 in the third shell. Same manner if you take an argon, whose atomic number is 18. So distribute the electrons, 18 electrons, 18 protons, 18 neutrons. This is understood. I am distributing the electrons here now. 2, 8, 8. So 2 plus 8 is 10 plus 8 is 18. That means this is the distribution. First shell occupies 2 electrons, second shell 8 and third shell is 8. It goes on. Suppose you are taking example calcium whose atomic number is 20. So it has got 20 electrons, 20 protons and 20 neutrons. Protons and neutrons, it's fixed. They are available in the nucleus only, fixed. Now coming to electron, electrons are 20. So this is the electronic configuration 2, 8, 8, 2. First shell. So remember like this once again I am showing you. This all come under one shell, K shell. Second, this is L shell. And this is M shell. And this is N shell. No problem. It goes on like that. 2, 8, 8, 2. So since it is 20. So this is how electrons are placed inside the orbits or they are also called as shells. So now carbon, as I told you, carbon atomic number is 6. So first shell will have 2 electrons, nucleus this is. First shell will have 2 electrons. Second shell will have 4 electrons, 2, 3 and 4. So you don't find third shell at all in carbon. Why don't you find third shell? I wanted it drawn just to show you that it has only 6 electrons. So first shell will have 2 electrons and second shell will have 4 electrons. That's all. This is how structural form. This is how electrons are filled in the shells. Now, as I told you, protons are how many now? 6 and neutrons are 6. That doesn't make any difference. They are present inside the nucleus. Now coming to, we cannot see this atom with our naked eye. It is so small. Now, if I suppose say draw a huge ball like this and one is like this, a small one. If I want to rotate my hand around this huge ball, say it takes 2 seconds for me to complete one. Imagine it is a still bigger one in front of us where we are able to move our hand around. Imagine that way. So it takes time for us to rotate. Minimum at least it will take 2 seconds. Now if I want to rotate my hand around this small one, within 1 second I can rotate 5 times because it is such a small one it is, okay, like this. Here it is not possible. Now what do you understand? Tell me. You are not able to see atom itself. In that atom there is a place called nucleus. Now size of atom will be greater than the size of nucleus because nucleus is inside the atom. So you can imagine if this is nucleus and the next one whatever you draw, that will be size of atom. That means size of atom is greater than size of nucleus and electrons are revolving around the nucleus. That means what happens if suppose they are not doing that one, but if suppose electron has to revolve around the atom, depending upon its size it will revolve. But now it happened to revolve around the nucleus, which is much more smaller than atom. And when we speak about the sizes, now we'll see size, velocity and all that about electron. Very interesting one. Size of the atom is, just imagine, the size of the atom is 0.53 in size, I am speaking of size, okay, into 10 to the power of minus 10 meter. This is the size of an atom. See, minus 10 means after 0.9 zeros, then these values start. So it is a smaller one, that is in meters, okay, 0.53 into 10 to the power of 10 to the power of minus 10. Now coming to this is the size of an atom. It indicates very clearly that this is atom. You can imagine this is atom, but still it is visible to my naked eye. So you cannot. I should simply say that this is atom, and you should also believe that this is atom because it cannot be seen your naked eye. Such a small. Now in that what is happening? Electron is there, yeah, electron, and this electron is revolving around the nucleus. See, atom is this much, nucleus is still small, and electron is revolving around the nucleus, which is smaller one. So naturally, quite natural, it takes very short time to complete its revolution. So the mass of electron, velocity of the electron is 2.18 into 10 to the power of, see, I am speaking about its velocity, 6 meter per second. This is the velocity of electron, means it is how much, around 21 lakhs 80,000 meter per second. Per second, imagine 21 lakhs 80,000 times an electron can revolve around the nucleus within a second. That means the size of the nucleus is very small. Simply, I don't know, if a small size object is suppose a big one, then it takes time for me. Even though if I try also, it will take little time. That means we can simply understand from this point also that size of the atom is very small, and in that size of the nucleus is much more smaller, and electron is revolving around the nucleus. Now coming to the time taken by electron to complete one revolution. Time taken by this electron to complete one revolution, one round. You know, how much time does it take? It takes 1.52. We are speaking about what time period taken by electron to complete one revolution. So it is into 10 to the power of minus 16 seconds. Very interesting, isn't it? So just imagine, it's not 1 second, it is not 2 seconds. It is minus 16. That means after 0 point, it is 15 zeros, then come these values 152. Very interesting. Microsecond, within that it is able to make one revolution. That is why it moves very fast. That is why it is said that electrons move very fast. This is something about electron.